Hello everybody, this is Basim who's joined the Graph, and you're watching the fourth video of the JanusGraph installation series where I show you how to install and configure JanusGraph and its storage backends on a Linux Ubuntu server. In this video I'm going to show you how to install HBase and how to configure JanusGraph to use it as its storage backend. First thing, we need to determine the version of HBase that's compatible with our version of JanusGraph. And to do that, I'll go to the GitHub website and I will search for JanusGraph. And I'll go to the release version that I'm using. Under the tested compatibility section, you'll see that it's compatible with Apache HBase, these versions. So I will use the latest version, which is 2.1.5. This is the version that we will download and install. Now I'll go to the Apache HBase website, which is hbase.apache.org. And I'll click here to go to the download page. And I couldn't find the link to download 2.1.5 from this page, so I'll go to the archive. And I will scroll down to 2.1.5. Here it is. And we want to download this file that ends with bin.tar.gz. So I'll copy the link location. Then I'll go to my Ubuntu shell. First, I'll navigate to /opt. And then I'll use the wget command to download the file from this URL. So the download just finished, and here is the archive file that was downloaded. I'll use the tar command to extract from this archive. I'll use -x for extract and f for the file name. And here is the archive file name. Okay, here is the folder that was extracted from the archive. I want to create a user. I want this user to be dedicated for running the HBase server. This will make it much easier to give this user the permissions that are needed by HBase and not more. And it will also make it much easier to find the HBase daemon process in case we want to monitor this process or kill it. So I'll create this user right now. I'll call this user HBase. So I'll say add user HBase. And I'll enter this user password. Okay, now we created the user. Let's now make this user the owner of this HBase folder and all its contents. So I'll use the chown command. I'll say -R to make it recursive because we want to apply this to the HBase root folder and all its contents. The username is HBase and the group name is HBase, and here is the folder name. Okay, so let's now go to the HBase folder and do ll just to make sure that HBase is now the owner of the root folder and the owner of all its contents. Perfect. So now let's switch to the HBase user because we're about to run the HBase server. And you see the folder structure is very similar to the folder structure of JanusGraph or the folder structure of Apache Cassandra. HBase 2 has a bin folder that contains all the executable files, and it has a conf folder that contains all the configuration files. So we want to start the server right now. This will probably be done from the bin folder. So I'll go to the bin folder and list its contents. And you see we have the file right here to start the HBase server. It says start-hbase.sh. So this is the shell script that we run to start HBase. I'll try running it. And we got an error. It says Java home is not set. And this is because we always need to set the Java home environment variable before we start HBase. So we have two things we need to do here. We need to find the path to the Java home folder, and we need to set the Java home environment variable to this path. So let's first talk about finding the path to the Java home folder. This path will be different depending on your Linux distribution and depending on which JRE or JDK package you installed. So here is how I found the Java home folder on my machine. I used which Java to find the path to the Java folder, to the Java command. And here is the path to the Java command. It's usr/bin/java. I'll do ll now to get some more information about the file at this path. And this file is actually a symbolic link that's pointing to the file at this path, etc. alternatives Java. So let's do another long list to get more information about the file at this path. And the file at this path turned out to be another symbolic link. You see the L right here. This means it's a symbolic link. And it's pointing to this file at this path. So let's do another LL. Maybe we have a third symbolic link. But no, this one is a regular file. So we have a symbolic link pointing to a symbolic link pointing to this file. And here is the actual Java executable, the Java binary. But we don't want the path to the Java executable. We want the path to the Java home folder. And the Java home folder will be one level above the bin folder containing the Java executable. So this is the path to the Java home folder, that path ending with JRE. So I'll copy that and I'll save it in Notepad so we don't lose it. And now that we have the path to the Java home folder, the next step is setting the Java home environment variable to this path. And here is how you normally set environment variables on Linux. You say export, and then the environment variable name, and then the environment variable value, which is the path to the Java home folder in this case. This will set the Java home environment variable. But I don't want to do that here. And this is because I don't want to have to remember to set the Java home environment variable manually every time before running the HBase server. HBase has a better way of doing it. So instead of this export command, we will use another method that HBase offers us. We will edit the configuration file. So I'll go one level up. So I'm at the HBase root folder right now, and then I'll go into the conf folder and list its contents. We have a file right here, hbase-env.sh. And this file can be used for setting the environment variables that are needed by HBase. So I'll open this shell script for editing using Vim. And if you scroll a little bit down, you will see we already have a line right here for setting the Java home environment variable. We just need to uncomment this line and change the Java home value to the actual Java home folder path on our machine. Here it is, and now I'll write this to disk and quit. Okay, so now that we're done updating the configuration, I'll try again to run HBase. So I'll go one level up, and then I'll go to the bin folder, and then I'll run start hbase.sh. And it started successfully this time, and now the HBase daemon is running in the background. Okay, we're done with running HBase. The next step is let's try to configure JanusGraph to use HBase as its storage backend. So I will go to the JanusGraph folder. It will be a couple of levels up. Now I'm in the OPT folder, and then I'll go to JanusGraph. And let me switch to the Janus user. The Janus user is a user that we created in a previous video for managing the JanusGraph files and running the JanusGraph server. I'll enter the password for this user. Okay, so we need to add the JanusGraph configuration to make it use HBase. So I'll go into the conf folder and I'll list its contents. And if you remember from the previous videos, these are the properties files, and the naming convention for the properties files, it's JanusGraph dash the name of the storage backend, Berkeley Java Edition in this case, dash the name of the mixed index backend, which is Solar in this case. So for this video, we want to use HBase as the storage backend, and we want to use Lucene as the mixed index backend. So we're looking for a properties file named JanusGraph-HBase-Lucene. We have JanusGraph-HBase-Elasticsearch and HBase and Solar. We have HBase without a mixed index backend. We don't have HBase-Lucene. So we will need to create this file. I will create this file by copying this file right here, the HBase without the mixed index backend, and we will add the configuration, the keys and the values to make it use Lucene as the mixed index backend. So I'll use cp command to copy this file, and the new file name would be janusgraph-hbase-lucene. So let's now open this new file for editing using Vim. And it already has all the configuration, because we copied an HBase file, it already has all the configuration to set the storage backend to HBase and the storage host name to the loopback address, because the HBase server and the JanusGraph server are running on the same machine. And we just need to add the configuration to make it use Lucene as the mixed index backend. And I don't remember the keys and the values for Lucene, so I'll cheat this from another properties file. First make the font bigger. /janusgraph, and then go into the conf folder. And let's copy the configuration from this file, from janusgraph.berkeley-ge-lucene-properties. We'll copy the Lucene properties, property names and values from this file. So I'll open it for editing using Vim. And here are the two lines for making it use Lucene. It sets the index search backend to Lucene and the index search directory to the JanusGraph root folder, and then db and then search index. This is where the Lucene mixed index information will be saved. It will be saved in this folder. So we need to get these two lines from here and put them in the file that we're working on. I'll copy everything, including the comments, and I will paste them in this file. And then I'll write this to disk and quit. Okay, so we just created this configuration file, janusgraph -hbase-lucene.properties. And if you remember from previous video, the configuration entry point is actually a YAML file that points to one of these properties files. So we want to edit this YAML file to make it point to the properties file that we just created. And this YAML file, it's located under the Gremlin server folder right here. So I'll go to the Gremlin server folder and I list its contents. And this is the YAML configuration file that's used by default by the JanusGraph server if we do not specify any other configuration file. So I'll open this file for editing. And this is the line that we need to change right here. Right now it's pointing to the properties file that is janusgraph-sql-lucene.properties. This will make JanusGraph use SQL, which is Cassandra, for the storage backend, and use Lucene for the mixed index backend. We want to change that. We want it to use the properties file that we just created. So it will use janusgraph-hbase-lucene.properties, which is the property file we just created. Then I'll write this to disk and quit. And that should be it for the JanusGraph configuration. We made all the necessary changes to the JanusGraph configuration files to make JanusGraph use Apache HBase and use Lucene. Now let's run the JanusGraph server. So I'll go 2 levels up to be in the JanusGraph root folder, and then I'll go to the bin folder. And this is the shell script that we run to start the Gremlin server or the JanusGraph server. And right now I'm logged in as Janus, which is with the user we used to run the JanusGraph server. Okay, so the JanusGraph server finally started successfully, and it's listening to this port 8182. Now I want to test this JanusGraph server from the Gremlin console, just to make sure that the JanusGraph server is able to communicate with its storage backend with HBase. So I'll go to another um, terminal window, and I'll quit this Vim file first. And then let me switch to the Janus user. I'll go one level up, so I'm in the JanusGraph root folder, and then I'll go to the bin folder. And this is the shell script that we run to start the Gremlin console. So I will run this shell script. And the Gremlin console started successfully. Now I want to connect this Gremlin console to the JanusGraph server that's currently running. So I'll do remote connect tinkerpub.server, and then the configuration file is conf/remote.yaml. Okay, so this connected it to the JanusGraph server. Now we want to send all the following commands to the server. So to do that, I'll say remote console, and this will send all the following commands to the server without having to precede them with colon and greater than. First thing I want to do, I want to check to make sure that JanusGraph is using HBase as its storage backend. So to do that, I'll get the string representation of the graph object. And here is the string representation of the graph object. It says HBase, so it is using HBase as its storage backend, and the HBase server is running at this loopback address, because both the JanusGraph server and the HBase server are running on the same machine. Okay, perfect. So it's using our configuration as expected. Next, let's check to see if the graph is initially empty. I'll say g.v.count. So there are no vertices. The graph is initially empty. Let's try adding a vertex. I'll say g.addv. And the vertex label will be person. And let's give it a prop. Let's give it, type it again, g.addv person. And it has a property. The property name is name, and the property value is p1. Let's try adding this vertex. Must have typed something incorrectly. G.add. Oh, I misspelled property. Okay, this one should work. Okay, perfect. So we just added a vertex, and here is the new vertex ID. So this proves that JanusGraph is communicating with Apache HBase without problems, because it was able to add this vertex and save it to the HBase database. Now I want to take a look at the HBase table, see how this graph data is being stored in HBase exactly. So let's open another tab, and I'll switch to the HBase user, and I'll go to the HBase root folder to start. And I'll go to the bin directory under the HBase root folder. And I want to run the HBase shell, which is the HBase client that we use to look at the HBase tables. So we have this shell script right here, HBase. So I'll run that, and I'll give it the argument shell. This is what you do to run the HBase shell. Okay, so the HBase shell was started successfully. And I will now run the list command to list all the HBase tables. And we see we have only one table called JanusGraph. This is the table that was created by JanusGraph. Let's get the description. Yes, describe this table. Okay, so this is the description of the table that was created by JanusGraph. Let's now try to see the data in this table. So I'll say scan JanusGraph. So this is the data stored in this table. You see it's using 12 rows to store the graph data, and we have a graph with only one vertex. So it used 12 rows to store this vertex and its properties and possibly other information about the graph. Let's try adding another vertex, another person vertex, and let's call this other person P2. So the second vertex was added successfully. Let's now see how this affected the tables. We had 12 rows before. Let's scan the same table again. And now we have 15 rows. So 3 more rows were used to store this other vertex and its properties and its values. Okay, perfect. Now let's try adding an edge connecting P1 to P2. So I'll say g.add e, and I'll give this edge the label knows. So one person knows another person, and this edge will go from g.v, and I'll get the first vertex by its ID. 2, it will go to the second vertex. I'll get the second vertex by its ID. So this should create an edge connecting person P1 to person P2. And the edge was created successfully. Now let's take a look at let's scan the HBase table again, see how many rows this added. We were 15 rows before adding the edge. Now after adding the edge, we have 18 rows. So 3 more rows were used to store this edge information. Okay, I mean, you see that the data is not really human readable, but at least now we know where JanusGraph stores the graph data. That's it for this video. Thank you so much for watching. I hope you enjoyed it, and please stay tuned for more graph database videos.